Start recording. All right, so we do have recording. So what we'll do today is to review exam one from the previous semester. And this is what I said I would do today from last Thursday. So I hope you had a chance to take a look at exam one from last semester and got a chance to kind of try to work out the problems because that would be super helpful to you, not so much to me. So what we'll do is we're going to get started here. All right. So let me look for that file. It's exam one, and this is the PDF version. Basically, you're going to get something about the same. It is a paper, it's a pencil on paper or pen on paper, whatever writing instrument you choose to use. But it's going to be on paper. It is open book and open notes, but no electronic tools other than a calculator. Okay, so if you want to bring a calculator, it's all good. But I don't think the math really requires a calculator. But if you want a graphing calculator, even, that's okay. So, do we have any questions about what is allowed? Yes, you can print whatever is on paper. You can bring. If it is a dead tree or parts of a dead tree, you can bring it. All right. So there's no limitation in terms of how much material. So if you bring all your handwritten notes that you have been taking during class, um, your own study guide, all the stuff that I have published, on Canvas, or if you know people from previous semesters and you have all the previous exams, you can bring those too. You can bring those with you as well. Just remember, the more stuff you bring, the harder it is to find the one thing that you need in case you need it. Okay, so there's definitely a downside of bringing too much. So does that answer your question? All right, excellent. So no computers, no cell phones, no tablets, that sort of thing. But as long as it is on paper, you can bring it. Okay, and that includes screenshots of all the recordings of the videos. And I have recording of this class for 15 years at least, and basically I teach this class at least twice a year. So there are many semesters of video recording, and you can take screenshots and bring those with you too. All right. Are we good with what you can bring in exam one, which is next Tuesday, by the way? We're good? All right. All right. So you definitely need to identify yourself in the exam. I prefer that you know what your student ID is because that is unique and I can easily kind of enter your grade using just your student ID. But I have had people who do not remember their student ID. In that case, you can also put in your last name and or first name. Okay. All right. So these are just basically the rules of the exam. It is an individual exam specific to the student with the ID that you put in here. So no collaboration is permitted in the attempt to answer the questions of the exam. I just need to make it extra clear. I know most people understand this part already, but I just need to make it extra clear. Paper-based content that was prepared prior to the exam can be used as long as no interaction or collaboration is involved in the attempt to answer questions of the exam. So that means, if somebody forgets to bring, the paper and all the notes, people cannot pass notes around in the class during the exam. So just make a note to yourself, okay? Make sure that you bring whatever you need on that day because I cannot let people pass material around on that day. All right? Cool. Um, do not share or discuss any parts of the exam until the next class meeting or otherwise permitted by the instructor because some people may miss the exam for legitimate reasons. And what legitimate reasons, the legitimate reasons are all listed in the syllabus. So you definitely need to read the syllabus if you want to know what the legitimate reasons can be. Grading is based on the explanation and steps, demonstration of the understanding of the knowledge and problem solving skills, and not just the final answer, unless otherwise stated in the question. If an earlier part of a question is answered incorrectly, partial credit may be given to a later part. So that means I reserve the um, agency to determine whether partial credit will be given to a later part when an earlier part of a question is answered incorrectly. Is that okay? So I would try to be fair, but sometimes I look at certain types of answers and I go like, nope, I cannot give partial credit for all the later parts. Okay, sufficient explanation means your answer connects definitions and concepts discussed in class via logical and or mathematical steps to find the answer of a question. You can write your answer on the exam itself, but if you want to bring your own pieces of paper to write on because they're lined with the right spacing that you like, you can definitely do that as well. Okay, so there's no limitation that you have to write the answer on the exam itself. I will try to provide enough space for people who do not want to add additional sheets of paper, but you can definitely bring additional sheets of paper if that is what you want to do. Um, all questions carry equal weight, which is really helpful because that gives you the flexibility of deciding which question to answer first. Okay, so my recommendation is to take a quick scan of all the questions. Make sure that you read, both page the first and also flip over because I print using how do you call it, duplex, right? On both sides of paper. So you definitely want to make sure you don't miss half the questions. Um, but because all the questions carry equal weight, that means it would be wise to start on the question that you think is the easiest to start with, because that way you can get all the easy points first, right? And then you move on to the harder question. So if you do run out of time, you basically optimize your score already because you're answering all the easy questions first. Now, what is easy to one person can be difficult for another person. And I cannot really evaluate which questions are the easier ones and which ones are the hard ones. So you are free to answer the last question first and then go back to the first one. Do it in whatever order you want. Okay. But the key is you can use this technique to optimize the use of your time. I will not extend the time of the exam past the end of the lecture period. So that means the exam will end at 6:50 p.m. Yes. So for this class, it is the entire lecture period. So it will start at 5:30 and it will end at 6:50 p.m. I cannot tell you because I really do not know. Um, every semester I make changes to the questions. So I can tell you that most of the time it is not a limitation of how quickly people can write down the answer. Most of the time it is a matter of whether people understand the concepts and can solve the problems or not. I would say it's not quick per se. I would probably say you probably need at least the majority of that time. So out of the 80 minutes, I would say, the most students will need about 60 to 70 minutes. Yep. For this class, I don't really see people walking out, really quickly and in these exams. All right. Um, and I also, um, most of the time I do, but I reserve the right not to. But most of the time, I also adjust the highest score of the exam. This class currently has about 23 students, so that means the 10 percentile is going to be probably the third or the fourth highest score of the class. Okay, that's about 90 percentile. So what I usually do but once again, I reserve the right not to do it. So what I usually do is I look at that person, which is your score the third highest or fourth highest in this particular class, and turn that into the new 100% and rescale everybody accordingly. But it is going to be a linear rescale, okay, which means it doesn't help someone who got a zero out of the entire test to begin with, because zero times whatever is zero. So this won't help people who really do not understand anything about the material. But at the same time, it also guarantees a few. Well, it doesn't guarantee because we can have like a three-way tie to have the highest score. So all of those people would end up with 100% under the rescaling. But most of the time, we don't do that. Okay, most of the time, there's um, no tie at the first three people. So that means some people might get more than 100% out of the exam. So is that okay? So once again, it is a typical thing that I do, but there's no guarantee that I would do it. Okay, because it kind of depends on whether it makes sense or not, and I cannot tell whether it makes sense to do it or not until I have seen the distribution of the grades. All right. Um, So let's just say that I make this test really hard, okay? The best student of the entire class could only get to 3 out of 4 questions. So that means the highest score is about 70, 75%, okay? So that means, I would take the third highest score again. Let's say the highest score was 68% out of 100. So that 68% becomes the new 100%, and everybody in the class will get a rescale accordingly. So does everybody understand the quote unquote rescale mechanism? Okay. All right. And in this case, I also provided some symbol definitions and whatnot. So it is probably helpful to try to read the instructions entirely. All right. So this is question number one, and question number one can be challenging to some people. Like this question number one can be challenging to some people. It may be easy to some other people. I cannot really gauge whether most people, whether you will see it as an easy question or not. Okay. So in this case, he'll read the entire question in the following space, explain how to conclude the given statement on each line. The explanation on each line can only utilize statements in earlier steps. You cannot change the order of the explanation, reference the number of the statements. If you are visual, you can use the long addition subtraction table to visually aid your reasoning. However, I only score based on the following list of explanations. Each line can be explained by just statements already given or explained, comma separated. You do not need to use English to explain. However, please be complete and quote all, but also only directly related statements leading to the concluded statements on each line. Since all the bits values are resolved, scoring is based on the proper explanation of the given statement on each line. Okay. So you can see some of these are saying no need to explain this is given. So obviously those are worth 0 points, right? Because it's already given to you. First thing first, on the first statement, what is it saying? Because if you cannot read what T2 equals to exclamation point X1 times Y1 plus, or what looks like plus, not exclamation point Q1 dot T1, that means you don't have a chance to actually answer all the questions. So what does it mean? So we'll do it step by step. What does T2 represent? In all the materials that we have talked about, what is the symbol T used for? And it has a subscript. Hmm? It's kind of like a borrow, okay? It is on the fourth row in a bitwise subtraction. It's a multi-digit subtraction topic, okay? This is the fourth row of the subtraction mechanism that we have been using in this class. So is that okay? Now, if you have a recollection or a general kind of recollection of, yeah, I know this has to do with subtraction, but I cannot really remember the definition, I need to look it up, you're probably okay because you know where to look it up, okay? On the other hand, for people who basically say, I have no idea what T2 is representing. This is all new to me. I would start to worry. Okay, but you got a week to study, so I wouldn't be too desperate, but I would definitely make an effort to study and understand the material. Okay, moving on. What is exclamation point X1? What does the exclamation point mean in this case? Hmm? It means a logical knot. Very good. Okay, so I'm borrowing that from C++ notation. What about this little dot here? What does that mean? It is and. Very good. Okay, who said that? Okay, very good. Okay, so the dot means and, because otherwise I have to use the wedge symbol, which is a little bit harder for me to type. So the dot means multiplication. It is not multiplication. It means conjunction. Okay, it means and. So if the dot means and, what about the plus? It means or. Very good. Okay. I did not use any parentheses in this case. So what is the order of operation? We'll just focus on, well, we'll take a look at the whole thing. So the negation applies to which part of the expression? It applies only to x1, okay, because that is the operator priority of the logical not operator in C++. Okay, I'm not changing the standards, I'm only changing the symbols. What about the priority between the and versus the or? Should I perform the and perform the and then or the result of the two and, or should I perform the or first and then use that result to end with this part and also use that result to end with the other part? And goes first, okay, and has a higher priority compared to or. That is also correct. Okay, so let's just say that somebody at this point goes like, I cannot possibly remember the operator priority of all the logical operators. What would be a good suggestion to those people? Look it up, print it out, and bring it with you. That would be kind of like a safety net, but I would just understand the material first, okay? Because I don't want to have to look up stuff when I'm answering the test. Because every time you have to look up something, you're using time. Instead of using the time to solve the problem, you're using that time to look up some knowledge, okay? So having that knowledge already in your mind before the exam is preferred, okay? It saves you time. All right. So now we go like, but tech, we never talk about this, okay? There's no place in your notes that explains that T2 is that formula, okay? So now what do you do? This exam is here to actually help you study. Because if you look at this stuff here and go like, oh, I know exactly why that is the case, that means you're already understanding the material. Okay. The additional stuff is really just to practice. Okay. On the other hand, if you don't understand why I can define T2 to be like this, then what do you do? I know some people are thinking, but you are the professor. You have to tell me what I'm supposed to do. Well, but at the same time, you're the student. I assume that you know what a student is supposed to do in a class. What did I tell you guys to do? Understand the material right after the class, right? So how is T of something defined? Okay, so T of, typically I use I plus 1 equals to what? So let's just say that this is a general multi-digit subtraction. I'm not talking about base 2. I'm talking about, let's say, base 10. Okay. So what does it look like in this case? Now this is definitely in my notes. Hmm? It's b of xi, yi, and this one is a actual plus. Okay. Originally, it really is a plus. B of q of t, qi, ti. That is correct. Okay. So if this definition looks new to you, and you're copying it right now because it is entirely new to you. Some people are copying just because, okay, I just write it down one more time, so this way it's easy for me to remember. But some other people may not have remembered this entire definition at all. So why? So my question to those people is, why is this new to you? Did you not read the notes? Did you not read your own notes? Because we talked about this in class. So those are the questions. I'm not trying to criticize, I'm not trying to judge, but I'm really just asking those questions because when people ask the question of why, what is this? We already talked about this. Okay, so the question is, how did some people miss this part? Because this is kind of derived, but it is also explained in the notes. Okay, so it is knowledge. All right, so let's just say that somebody goes like, okay, I remember this. Then how does it become that on the projector? This works in general. Okay, it works in base 10, works in base 2, works in base 8, and so on and so forth, depending on how, the way you define the B function, okay, the borrow function. So in base 2, okay, how do we define the borrow function? So in base 2 only, okay, in binary only, B of UV is defined to be what? And I want the definition that only makes use of logical operators. So how is it defined? Yes, yep, that is correct. Not you. And I believe when I talked about this in class, I put in extra parentheses just to be sure, the order of the operation. Does that look familiar to you on the projector? Do we understand why T of 2 is now defined as not x1 and y1 the whole thing, or not q1 and t1 the whole thing? Do we see that connection? Okay, so that is what you need to do. Okay, you need to make sure that you have all the definitions. This is a definition. This is derived, but since it is already spelled out in the notes, okay, it is also a definition of sorts, even though it only applies when we're dealing with base 2 numbers. Are we okay so far? All right. So, given that, now we understand what one is saying. Okay, statement one is just spelling out how do we compute T2 out of x1, y1, q1, and t1. Okay, then line two is kind of the same thing, but except it explains T of one. What about D1? And what about this symbol here that looks like a plus in a circle? What does that mean? Exclusive OR. Okay, it means exclusive OR, otherwise known as XOR, XOR, because exclusive, the X, sometimes people just put the X, the letter X. Sometimes people call it EOR, because exclusive OR starts with an E, but it is exclusive OR. Okay, this is also explained in the notes. Okay, D of 1 is the exclusive OR between Q1 and T1. Okay, so basically from the the statements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are more. They are really just kind of restating things that we have already talked about. Same thing with line. So 10 is good. 12 is also one of those. Okay. In other words, sometimes I interleave things that are given to us and things that we need to derive. Are we doing okay so far? Okay. So now the first actual question is number 11. So number 11 is basically saying, okay, for some strange reason, we know that not x1 and y1 or not q1 and t1 is false. Why do we know that up to this point? In other words, you can only use a combination of statements from statement 1 all the way to statement 10. You cannot use anything after that. So which two or which ones do you think will explain exactly statement 11? So I'm going to put this on the whiteboard. Okay. So for question for number 11, which two should I quote? Well, let's try to do a pattern matching now. Okay. So which one mentions not x1 and y1 or not q1 and t1? Looks like statement number one is involved. Okay. But that does not link the value of the expression to false. Okay, so now we have to say, okay, one is cool, okay, but it is just relating T2 with a equation expression of some kind, but it doesn't say the expression is a zero. So you have to look a little bit more, okay, and then we look at 10. 10 says T2 is a zero. So that means 1 and 10 together is the reason why we have 11. When you combine those two, then we know the expression not x1 and y1 or not q1 and t1 is false. So you need both of them. Are we doing okay so far in terms of reasoning, and also what the answer is supposed to be? Yes. You just quote the number. Yes. Yep. So this way, the writing part should not take you a whole lot of time. So you spend most of the time just thinking, which two or which sometimes it's up to three, that are related and come to the correct, conclusion. Okay. Very good. Good question. Number 12. Okay. It's already given to you that there are no points associated to number 12. So now we move on to number 13. So on number 13, the conclusion is we know not x1 and y1 is false. How do we know that? Yep, that is correct. 11 alone explains that. Okay, so if I don't have to explain this, I would not explain it, but does anyone want me to explain this? Okay, I see some nods. Okay, that's cool. So 11 is telling you the result of an OR is false. Okay, so you think about the truth table of OR. There's only one row of the truth table of OR that results in false. The only time the result of an OR is a false is what? Relative to the left-hand side and the right-hand side. They both have to be zeros. So that means by observing 11, which is already confirmed at the time when we have to work on 13, we know the left-hand side of the OR has to be false. The right-hand side of the OR also has to be false. So right there, we make the conclusion that um, not x1 and y1 has to be false because it is the left-hand side of the OR. So that means 11 alone explains number 13. Then we move on to number 14. Same thing. 11 alone can explain that. And then we move on to number 15. So 15 is making a conclusion that Q1 has to be a 1. So how can we make that conclusion? Yes. Exactly. Yep. Nope. You don't have to explain. You just do the exactly the same way that I do on the whiteboard. That's cool. That is fine. One or more, as many as you need. And I can already tell someone, has a strategy because that's what I would have thought of already at this point is I'm just going to quote all the numbers before a certain number. That would guarantee whatever is the actual answer is in my answer already. I would look at those answers and give a zero to that particular one because it illustrates that person did not understand anything about the statements. So don't even try that approach because it's not going to work. All right. So moving on to number 15. So number 15 says, for some reason, we can now single out Q1 and conclude that Q1 has to be a 1. How can we make that conclusion? Hmm? 9 and 14. I would say 14 alone is enough. Okay. Oh, wait, wait. You're correct. 9 and 14 is, yep, 9 and 14 is what we need. Sorry? 13? 13 and 15. Okay, so how would 13 help in number 15? But how does that have anything to do with Q1? 15 is concluding that Q1 is a 1. Yes. So how do we know Q1 is a 1? By only observing that not x1 and y1 is a 0. Yep, we don't have enough information. However, using 14, 14 and 9 together, we'll explain it. Okay, so I'm going to write it down first, 9 and 14. 14 alone is not enough to explain Q1 is a 1 because if T1 is false, then we have no idea what Q1 is. Does that make sense? Okay. So that means I need to know whether if we know T1 is a 1, which is what 9 is telling us, then the only time this AND can be false is when not Q1 is false. Is that correct? But in order for not Q1 to be false, Q1 has to be true. And that's how we can make that conclusion onto line 15. Are we doing okay so far? So all of this reasoning can be done using truth tables. Okay, if you know the truth tables for all the Boolean operators, including exclusive OR, that's all you need in order to come up with the answers. So the question is not whether you can do it, the question is how quickly you can do it. So the more you practice, the quicker you can do it. Excuse me. Now we move on to line 16. Okay. Yes. Line 11. And then which one? Okay, so let's take a look at line 11, 13, and 14. Um, that is insufficient to conclude that Q1 is a 1. Well, it's kind of the other way around. Why is it sufficient? So how can you lock down the value of Q1 to be 1 only looking at 11, 13, and 14? So I will do the reasoning kind of in a backward way. Line 13 and line 14 implies 11. In other words, line 11 does not give me any extra information. So we really are just working with line 13 and line 14. Line 13, um, so the only reason why line 13 may be able to tell us the Q1 is a 1 is if we can lock down the values of x and y, x1 and y1 directly. But it does not, right? Because y1 can be false, making the entire conjunction false. X1 can be true, making the whole thing false. But I cannot relate x1 and y1 using 13. Do you see why that is not sufficient? Okay. And then I look at line 14, it also at the same time does not give me, it cannot lock anything down, okay, because I can use the same argument, because T1 can be false, making the conjunction false, Q1 can be true, making the conjunction false, but I cannot tell, they can also happen at the same time, but I cannot lock down which one. Yep, correct. So if you add 9, okay, 9 really is the key, okay, you cannot not have 9 and then make the conclusion that Q1 is a 1. So now the question is, what if it is not just 9 and 14, which is the bare minimum that you need, and you also include 13? I will give you partial credit. because it is not just the ones that you need. It also includes one that does not have anything to do with the conclusion. So I would give partial credit in that case, and probably it's going to be a 3 out of 4 kind of partial credit. Yep. Say that one more time. You can only use statements that are prior to the one that you need to explain. So you cannot use anything below. You can only use things that are already established. That's what the question is saying. Or, that's the constraint. Yep. So that is okay. So I don't want people to overstudy. Okay, this is the nature of the test. Okay, the nature of the test is, you know, it will involve some kind of reasoning that is based on what you have learned, but the actual application of the knowledge may or may not be something that we have talked about in the class. Is that okay? All right. So now let's work on number 16. Number 16 is a direct result of 11, right? I think number 4. No, wait. Nope. Number 16 is 9. Okay. 9 and 15. Yep. Okay, so the reason why it is 9 and 15 is 15 already tells you that Q1 is a 1. So you look at the truth table of exclusive OR and you say, if I already know the left-hand side of exclusive OR is a 1, but I need the result of the exclusive OR to be a 0, only one row matches that description. So the only one row of exclusive OR that matches that conclusion is when the right-hand side is false. Okay? Or, yeah. Wait. Oh, wait. I take it back. Okay, I was explaining something else. Okay, this one is actually more straightforward because we know what is Q1 and we also know what is T1. Putting those in, it is just a direct lookup of the exclusive OR table. So I take it back. I was thinking about something else, something a little bit more tricky, but it was actually this one is a lot easier because we already know what is the value of Q1. We already know the value of T1, so it's straight up just figuring out what is the exclusive OR of two known values. Okay, number 17. Number 17 says here we have a conclusion of D1 is false. This one is kind of easy because D1 is defined up here using number 3. So we know 3 is useful. And we also know 16. So 3 and 16 together concludes number 17. Because 3 is telling you that D1 is Q1 exclusive of with T1. 16 tells you Q1 exclusive of T1, which is the entire right-hand side of the equal of number 3. We tell you that it is a 0, so you just put those together. You can make a conclusion that number 17 has to be true. Number 16 by itself does not explain 17 because you're not linking the exclusive OR to D1. Yep. So you need number 3 to link the expression to the bit D1. Yep. So that's a good question, okay? Because this is a good exploration because we're exploring. What if I only answer with this part? Well, that doesn't work entirely. You get partial credit if you do not quote number 3. You still get partial credit, but not the other points. All right. So number 18 then. So we're looking at number 18, which is the exclusive OR between x1 y1 has to be a 1. Okay. So nope, it's 4 and 15. That is correct. So number 4 gives us the definition of Q1 being the exclusive OR between x1 y1. And then 15 tells me that q1 is a 1. So now I can make the conclusion that x1 exclusive OR with y1 is a 1. So number 18 and number 4, whoops, nope, I cannot. Self-reference, it is uh, q1, which is number 15. So 4 and 15 together makes the conclusion for number 18. Is that okay? We good? Yep. Question? Line 13 is not enough information because it is only telling you that, um, okay, so once again, the question is why does it tell you enough information? Exactly, because it does not. You cannot prove something does not exist. The, the burden of proof is always on the person who says something is true or exists. I'm not sure whether that makes sense or not, but you cannot. So line 13 is telling you that not x1 and y1 is false. So there are several possibilities to make this statement false, right? So that means y1 can be false. But if y1 is false, then I cannot lock the value of x1 at all. So that means x1 can be true, x1 can be false, but that means I cannot lock down the exclusive OR has to be a 1. Likewise, you can say, well, what if x1 itself is true, then the negation of x1 is false, but then I cannot lock down y1 either, because in that case, when one side of the AND is false, the whole thing is guaranteed false. I cannot use that to lock down the other side of a conjunction. So that means it gives me too much degrees of freedom to actually make the conclusion that x1 exclusive of y1 has to be true. So I hope that explains why that 13 alone is not enough as the answer. Yep. You cannot use 21 because 21 is after 18. Huh? 21 and which one? 21 and 13 would not be enough because 21 says one side of the conjunction is false, the right hand side is false, which says nothing about the left hand side. So I still have the flexibility of the okay, so you're using 21 and 13 to show 18. Okay, so if we do ignore that 21 is out of order, okay, so let's look at 21 and 13, and we're trying to use it to prove this. So the only thing that is locked down is y1 is a false. So if y1 is a false, that means we do not know what is x1. X1 can be true, x1 can be false. So I still cannot, huh? Why does it have to be a 1? Because it's an AND. If y1 is a false already, the AND is automatically false. You cannot make any conclusion about the left-hand side at all. Yep. So you have to make sure that you distinguish between AND versus OR, because the type of conclusion you can make really depends on the operator itself. So as a hint, okay, to help you with questions like this, and in general, okay, because I think we rely a lot on operators. Having a truth table handy can be helpful because when you're deep in trying to answer these questions, you might actually have some fog of okay, I'm too much into this, I cannot remember what is the truth table of and or having that table in front of you can help you go like, okay, this is the truth table. I apply the truth table, and now can I or can I not make a conclusion? So having that table visually available, during the test can be helpful. All right, so we are down to 19. Okay, so 19 says, that kind of long-ish expression is true. So how can we make that conclusion? It is number 18 itself, because that's how we define exclusive OR. So the expression of x1 exclusive or y1 is the same as not x1 and y1 or x1 and not y1. That's kind of by definition, it is mentioned in the notes. All right. So number 19, and then here's 20. All right. So 20 is fairly easy, okay? See, because 20 is so we know 19 is probably involved, okay? Because 19 has exactly x1 and not y1 in it as well. But because this is an or, that means, well, if at least one side is true, the whole thing is going to be true. So I cannot use 19, only 19 to make a conclusion of 20. If I need to make a connection between 19 and 20, I need to rule out the left-hand side being a 1. But we made that conclusion earlier, which is number 13. So that means 13 and 19 together will make a conclusion of 20. Are we good so far? So you can see this is really just application of the truth table. So I'm gonna scroll a little bit here. Okay, we'll scroll down to, oh, okay, well that's we're almost done. The other two are pretty easy. Number 21. So number 21 says, okay, now we know y1 is false. How do we make that conclusion that y1 has to be false? 20 alone. Does that make sense to you? Because line 20 says x1 and not y1 is true. You look at the truth table, okay? The only time a conjunction can be true is when both left-hand side and right-hand side are true. So that means I lock down both sides of the conjunction because the conjunction is true. So number 22, same way, line 20 alone. So that's on the whiteboard. That is the answer. All right. So are we getting a hang of this? Yes, maybe. Okay. So if you have been practicing a little bit with binary subtraction, this stuff may come in a little bit more intuitive because you have been performing these bitwise operations for a while. If not, well, you got a whole week. You can still practice a little bit more. Shall we move on, or do we have any additional questions about number one? Well, I guess I should bring this up. Okay, so let's just say that you got to number 18, and there are four questions in total in this case. Okay, in this particular exam, there are four questions in fall 2025. I have no idea how many questions you're going to get. So how much time should you spend on each question? I'll give you a few options. As much time as it takes. Okay, 20 minutes or 15 minutes. So which one is probably the best option? 15, okay, not 20, okay? Then you go like, but Tech, you don't know your division. 80 divided by 4 is 20, not 15. Well, you want to shorten that time just a little bit so that at the very end of the entire thing, you have time to go back to the question that you miss. Okay, you give yourself a buffer so that you can use that time at the very end, but no more than 20 minutes. Okay, so let's just say 20 minutes has passed and you're over here. If I were you, I would kind of not answer the rest, make a note, and say, okay, if I have time, I will come back and answer those additional parts because I answer a good portion already at this point. Okay, I'm not getting a flat zero out of this question. I'm getting most of it. Okay, so I would just kind of move on to the next question. and then come back to this later. That would be my strategy. Doesn't mean that you have to use that strategy because some people may think, I got the momentum going. Okay, I'm in the flow of this kind of question, so I'm just gonna spend some extra time to finish up the other 5 questions or 5 parts. That's also valid. Okay, so which way you proceed with or how you make the decision is entirely up to you. But the key point is to keep track of time, but in a way that does not give you anxiety or pressure. Now, that part is a psychology thing. I cannot really tell you how you can do it. Okay. I just know that I can do it. I can, okay. This is a psychological term. I can detach pretty well from pressurized situations. It's almost like looking at myself from above, kind of like people flying a drone, except I'm flying myself remotely. I'm not sure how well you understand that term, but it's kind of like that. Some people cannot do it. I can do it easily. Okay, probably says something about my childhood. Okay, and here's question number two. Okay, so question number two says, assume W is 6, and that is the width of all the bit patterns. Okay, so there's an assumption of W equals 6. Part 1, use the function VU applied to a bit pattern P. Explain and derive the bit pattern P that minimizes the value of VUPW. Show your steps and reasoning. Yes. Hmm? Oh, zoom in a little bit? Sure. All right. There we go. Yep. Okay. So part 1 says, okay, so that means what do you need? The definition of the VU function. Okay. So how many people can kind of quote the VU function with P and W as parameters offhand right now? Okay. Some people kind of do the wavy hand. Okay. If you can, okay, how many people know where to find it? It can be in your own notes, it can be in my notes, okay, but you know exactly where to find it. You can, given the material that you are allowed to bring into the exam, you can look it up in 10 seconds. Okay, so that is still good. Okay, that is still good. Okay, if you know where to find it, it's still good. Okay, so the answer to this question is all the bits, of bit pattern P, they need to be zeros because it is a straight up sigma of each bit of the bit pattern P times the corresponding power of 2. Okay, but because each bit can only be a 0 or 1, every power of 2 can only be non-negative. So that means in order to get to the smallest possible value, you just have to make all the bits equal to 0. Okay, so that's going to be the answer to part 1. So part 2 says use the same function VU applied to a bit pattern M this time. So there's a bit pattern P, there's a bit pattern M. Explain and derive the bit pattern M that maximizes the value of the function applied to MW. And it's the same W. Okay, so W is fixed at 6 over here. So in this case, how do you maximize VU, which is the unsigned integer value of a bit pattern M, interpreted up to W bits? Okay, that's what it means. They're all ones. So in this case, you have to tell me exactly 6 ones, okay, because W is 6. So no, because you, okay, if you just give me 6 ones, I don't know. So what is the actual value that you add up? So you have to say 1 times 2 to the power of 0 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 2. You have to expand it and then give me the actual value that is the result. So in this case, it would be 31. Nope, 63, sorry. It would be 63 because once you add up all the powers of 2, which is 1, 2, 4, 8, 16, and 32, you end up with a 63. because the question is specific to the W. Well, okay. So the key is if you just give me six ones, you are not explaining and you're not deriving. Okay. I think based on what you're describing, it's okay, but I have to actually see your explanation before I can make a judgment of. There are six parts, right, in the sigma, and you need each part to contribute as much as possible. And the only way for each part to contribute as much as possible is the bit being a one, because you cannot change the power of two. That part you cannot change. The only part you can change is whether the bit is zero or one, right? So you can use that as an argument. You can basically explain that to me. Mhm. All right. So now on part three, you're given two specific pattern in this case, um, and you are supposed to give me the long subtraction using all five rows. Okay. So now the question is, do you know how to do this? So I'll give you guys a little bit of time to think about it, and then I'll give you the correct answer on this side. All right. So x is 101101. Is a base 2 number. Y is 110110. We're doing a bitwise subtraction. Okay. How is so after question number one, depending on how people answer the question, but if someone answer question number one first, don't you think we know how Q is defined at this point? Let me ask that question again. Okay. If somebody decides to answer question number one first, okay, and not even to answer the whole thing, okay, just read a bunch of the given expressions. Um, by the time we answer this question, we already know the relationship between all the bits because Q of one is defined to be, okay, shall I go back and, so this is something that you can do as well, okay, if a part of a question seems to be answering another part, use it. That's not cheating. You're just basically using as much information as possible within the exam itself. Okay. So if that is the case, okay, I should probably just stay here because I want to finish the actual calculation. So that means, oh, this is x, this is y, this is q. So this is the exclusive or between these two, which is a 1, that's a 1, that's a 0, that's a 1, that's a 1, that's a 0. Okay. So if you say, okay, but Tech, we don't have like 40 years of experience. I cannot do it nearly as quickly. Truth table. Okay. Bring it with me. Bring it with you, not me. I don't need it. But that's kind of important. Okay. What about the T row? This is the T row. Oh, question number one tells me what to calculate or how what to do with T. Because T of 2 is not x1 and y1 or not q1 and t1. It gives you exactly what you need to compute all of the t bits. Okay, t0 is given to you in the question, so we don't have to compute that one. Okay, not x1 and y1 is a 0, not q, sorry, I take it back. Not x0 and y0 is a 0. Not q0 and t0 is also a 0. 0 or 0 is a 0. Not x1 and y1 is a 1. So if you look up the truth table, if it's a or, if one side is true, the whole thing is true already. Done. Okay. Um, let's see. I have to line up the columns. So we have. Oh, we are here. Not x1, 2, sorry, not x2 and y2 is false. Or not q2 and t2 is true. One side is true, the whole or is going to be true. Put the 1 over here. Not x3 and y3 is false. Not q3 and t3 is also false. False or false, false is false. Then we get back here. Not x4 and y4 is true. Hey, done. Okay. Not x5 and y5 is false. Not q5 and t5 is true. Done. Now I can do it relatively quickly because I kind of remember, all those things and I've practiced. But the definition is already here. So that is how you can use one portion of one question to kind of help you answer another question. Okay. Now whether your exam has this convenience or not, I do not know. Okay, because I have not, made up the questions for your exam yet. All right. So that answers part three. Now we get to part four. So part four is asking, given the outcome of the subtraction of part three, what is VUDW? So this is also a good time to tell people why. In some cases, the wrong answer of one part, I cannot give partial credit to the rest. So let's just say that somebody has absolutely no idea how to perform subtraction in base 2, but they read ahead and go like, oh, okay, so if I can get partial credit just for part 4, even if I get part 3 incorrect, I think making the all zeros is going to make it pretty easy to answer part 4. That is the reason why I cannot give partial credit in certain cases when an earlier part is already incorrect. Because in this case, I would interpret it as I'm going to intentionally use a specific wrong answer for part 3 so I can get part 4 right. That defeats the whole purpose of part 4. So, unfortunately, in that case, I cannot give partial credit to part 4. Does everybody understand the rationale why, in certain cases, I cannot give partial credit to a later part when an earlier part is wrong? Because I can tell that some certain wrong answers are not just wrong, they're engineered to be wrong in a certain way. Yes, then it is up to my interpretation. You mean for part four? Show how you use the definition to come up with the answer. So you have to meet that requirement. Yep. So here's okay. So to answer the question, okay. So now we look at. So that means I'm not done yet. I have to look at D. So I'm just going to quickly look at D. 1, 1, 1, 0, and here's a 1 and a 1. There we go. So that would be D. So the correct answer to part 4, and you have to spell it out, okay, is going to be 1 plus 2 plus 4, which is a 7. No 8, but we have a 16 and a 32. So 16 and 32 is a 48. 48 plus 7 is a 55. So you kind of have to show me the math, okay? Show me why you get to 55. Because I know there are calculators that can help you convert from base 2 to base 10. So that means, giving me the final answer by itself does not show me that you know how to make that conversion. So you have to show me the actual expression to come up with the value. Alrighty, so we are now moving on to part 5. Compute the overflow flag. Start with the definition of the overflow flag as a Boolean expression and substitute the parts with actual values to figure out the value. Show your steps. Okay, so that means you actually have to show your steps. Okay, the question tells you what you need to do. Start with the definition of the overflow flag as a Boolean expression. So do you remember the definition of the overflow flag? Hmm? Nope, that is not overflow. It's a little bit long. You guys got a lab to work on this one. So that means the lab can also be useful for studying. Okay, so it's not just limited to the lecture material or the video that I have recorded for the lectures. The labs can be useful too. Okay, when you're studying. Okay, so how do we define overflow? Okay, that is correct. Okay, yep, that is correct. But in this exam, okay, I cannot make guarantees about yours, but in this particular exam, I can look up a little bit up here and go like, oh, look at it here. That is also telling you how to compute the overflow flag. Okay? So, yes, but you're correct. Okay? That is the equation. That is the expression to calculate the overflow flag. The overflow flag is in the notes. Okay? So that means if you know where to find it, great. If you have copied that expression into your own notes and you turn your own notes into your study guide, great. Okay, because by the time you copied it the second time onto your own notes, from your own notes to the study guide, you probably have remembered that already. Okay, which means the very act to make the study guide also, in most cases, make the study guide itself unnecessary. Okay, which is usually the intention. Okay, and that's why when people ask me for a study guide, I go like, I cannot give you a study guide. I don't know how you study. I don't know what is important to you and how you look up information. So that's why only you can make up the study guide for yourself. Okay, so in this case, the overflow flag, because we have W equal to 6, so that means we have to look at the most significant bits. So there will be x5 and not y5 and not d5 or not x5 and y5 and d5. Okay, so in this case, that would be the Boolean expression for the overflow flag. And then you have to substitute with the actual values, right? So x5 is a 1, okay? So you put 1 over here. Y5 is also a 1, and then D5 is also a 1. Okay, but you have to remember this you have to negate first. This one you also have to negate. This one you have to negate. Then we have 1 and 0 and 0, or 0 and 1 and 1. This will give me false. This will give me false. False or false is false. Now, how you actually express and show all your steps, this is one way to do it, okay? But it doesn't have to be like that. I just need to know that you can follow all the steps, start with the definition, and then substitute the parts, and then figure out the actual value. So those are the steps that you have to show me. But whether you show me in that format or in your otherwise, however you want to show me, as long as I understand it, okay, you can still get full credit for this. Part 6, compute the L flag. So now you have to remember, start with the definition of the L flag. So where do you find the definition of the L flag? It's in the binary subtraction module. Okay, so people who did not read the module like at all, I hope this is coming back to haunt those people. Okay, because getting haunted 1 week before the exam is much better than getting haunted on the day of the exam. Okay, which also reminds people maybe I should read the module in the future because we still have how many weeks to go? About 10, 11 weeks, right? So that means you can change your strategy so that by the time you get to exam 2, it'll be easier because you have been reading the notes and trying to understand all the material. and so on and so forth. Okay, so the L flag is defined to be the sign flag, which is the most significant bit of D exclusive or with the overflow flag. We know the overflow is a 0 already, and we know the sign flag of D is a 1, so that means the L flag is a 1 in this case. All right. So once again, show your steps, blah, 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 blah. All right. So question number 3 is very similar, okay? Except I twist it around a little bit. Instead of using VU, I use VS over here. Um, and then we also have a subtraction, so that part has not changed. And then this part is not changed too much, but I'm using VS instead of VU. So you have to remember the main difference between VS versus VU, okay? There's only one minor difference. What do we do with the most significant bit? That is the only difference, okay? Just by saying that, even if you cannot remember how VS was defined in class, just by me saying we are changing the way we treat the most significant bit, that should remind you. It's like, oh, that's right. Okay, instead of potentially adding the highest power of 2 according to W in this case, we are subtracting it if the most significant bit is a 1. Okay, so if all of this is coming back piece by piece gradually, it's all good. This is me helping you study for your exam so that you can get a good grade on your transcript. Okay? I hope you guys understand that. Are we good? Okay. And people who are not happy about the way I teach this class, guess what? This is the semester I'm getting evaluated. We call it the performance evaluation, okay, which happens every 3 years. So you guys are the lucky ones because if you say, I hate the way tech teaches this class, you can write an essay about how you do not like the way that I teach. If you want to write it ahead of time so that by the time you get the evaluation, you just staple your multi-page essay on how badly I'm teaching this class, that's okay too. It's okay with me. And I cannot read that feedback until you get your grade this semester. So don't worry about retaliation. And you don't have to even have to put your name on the evaluation. But keep in mind that I do know your handwriting because of the way you turn in your exam. So you just have to write with your other hand with the evaluation. I'm pretty sure I can train an AI and go like, this is the right hand writing. So what would the left hand writing look like? If I get enough samples, I can probably reverse the whole thing. AI is really cool in a certain way, kind of creepy. Anyway, no, I'm not going to waste my time to do that. Don't worry about it. I got better things to do, like thinking about the exams for the next semester. All right, so this is almost it. Okay, this is question number 4. Um, we probably have to spend a little bit more time. Hmm. This is just space conversion and using subtraction. So I will. Do you want me to talk about this, or do you want me to? Okay, okay. I'll give you guys the choice. Do you want to limit the scope of this exam and stop with base conversion and subtraction and addition and comparison, or and then leave double, okay, the floating point number representation to the next exam, or do you want to include double the floating point uh, representation in this exam? I will leave it up to you guys. You guys can vote. So the good thing is, if we leave double to the next exam, the scope of this exam is exactly ending with this question number 4, okay, which is everything up to but excluding double or floating point number representation. The bad news is it'll be included in the next exam. Okay, there's a conservation of mass here. You're not getting rid of mass nor energy. You're just deferring it. or otherwise known as kicking the can down the road. So the question is, how many cans do you want to find at the end of the road? Hmm? One can. So do we have a consensus? How many people want to kind of put off the floating point number representation to exam two? Raise your hand if that is your preference. Nobody. Okay. So we are all agreed to have double. Okay. So that means I have to kind of do this one quick. Okay. So this is a subtraction in which base? Base 6. Okay. So we have to reverse this and go like, uh, what minus 4 is a 5 in base 6? Remember, there's a lab that kind of works like this too. Okay. So we are asking in a single digit subtraction, what is r of, in this case, x0, comma 4, and we need the result to be a 5, but in base 6 in subtraction. So what is the answer to this question? No, because 0 minus 4 in base 6 will give you a 2. Okay, so how do you define r in base 6? Okay, so let's go back to r of uv in base 6. Hmm? Okay, how is r defined in a base 6 subtraction, not addition? So once again, if you know where to find your stuff, great. If you already know what it is, even better. But if you go like, I have no idea what you're asking, that means you are going to get busy this week getting ready for the exam. Okay. So for subtraction, the R function is defined to be it's 6 the base plus u the whole thing minus v, and then take the whole thing and then mod it with 6. Okay. So that's one way to do it, not the only way, but one way to do it. Okay, so this is going to be what? 5. Okay, we know v is a 4. Okay, so now you have to figure out what u needs to be. All right, so let's just say that you cannot look at this and come up with what do we call it? The closed form solution. Okay, so if you cannot come up with a closed form solution, but we know u is a single digit in base 6. So that means how many choices do you have? 6 choices. U maybe 0, 1, 2, 3, 4, or 5. Plug in each one and see which one works. And then you can use that to answer the question. Is that the best way to answer the question? No. But if you have done this like 1 or 2 times, you would figure out the pattern. This is also what we did with one of the labs. So the correct answer to this question is um, basically it is asking, okay, what minus 4 is a 5? You go like 9, right? But it's not 9 because 9 is not a digit in base 6. 9 is referring to 6 plus u. So if 6 plus u equals to 9, what is u? Exactly. So that's how you solve this, okay? So once you have done this once or twice, you can figure out the pattern and then you go like, oh, okay. So now we can figure out this is going to be a 3, this one is going to be a 5, and this one is going to be a 5 too. Okay? So once you figure that out, then you go like, uh, the t works out kind of the same way as what we talked about earlier. Okay, this is a 3 minus 4, so we would have a carry, I mean a borrow one over here. 0 minus 1 is going to have a borrow over here. That's going to be a 0 because this is 5 minus 4. This is 1 minus 1, and there won't be any borrows after beyond this point. So the overall borrow is going to be a 0. And then we just have to work out d, which is a single digit subtraction again, using the r function. So I can give you the key. Okay, I have the key already available. So I will send you the key to this particular exam. And we are running out of time today. So that means the double or the floating point number thing, I have to talk about it in the next lecture. or I can record it and send it to you. That works too. But this is the question in because in the previous semester I did kick the can down the road. So the floating point number question was in exam two. So if I put a floating point number exam question in exam one, then exam one is not going to be as long as the exam one that you just saw. Okay, because otherwise there won't be enough time. So this one, okay, is me giving you a bit pattern, and then we are reversing back to what that bit pattern would be representing as a value when interpreted as a double precision floating point number. And it is a very step-by-step kind of thing, okay? Now, technically speaking, I really do not need to go over this because we have done it. We just did it on what, last Thursday, right? It's the same process, okay? It is exactly the same process, except the bit pattern is a little bit different in this case. But the process is still the same, okay? But if you guys want to, we can kind of work out question number three on Thursday, on this Thursday. It shouldn't take long because it would be the same thing that we talked about on last Thursday. But I do encourage that you try to do it first because um, it's something that we have talked about already. If you try to do it yourself, that way you are essentially studying for the exam. Yes. Yes, I sent a second announcement. It is on the second announcement. But you only have to worry about question number three for in the exam of the second announcement. Yep. All right. So we are now moving to the lab portion. I do have a lab because most people think, oh, today is the review day, so there won't be an exam or quiz or lab. The answer is no, I do have a lab for you. And the lab specifically is to remind you of the topics that we talked about today. So, let me see, where is it? Exam one practice questions. There we go. All right, so I just have to make it visible, give you the access key, which is not very exciting. It is just X1 for exam one. I hope BMW is not going to sue me for infringement of their model. What kind of stupid car company would name a car X1? Hmm? You mean next Tuesday? For next Tuesday, there won't be a lab after. But if anyone wants to kind of talk about the exam question and the answer, I will be available to talk about. Alrighty, I'll see you all in the lab.